Hey, this is Mr. Weiswald. We're reviewing the rubric for the game, and we're going to use that partially to review for the final as well. So sit tight, grab your rubric in hand, and we're going to get going. All right. Have you got your rubric? Looks like this. Looks like this right here. Periodic table rubric. Feel free to take notes on that as we're going along, and especially for stuff that you're still confused on. That'll help you get up to speed a little bit. A couple announcements before we get started. There's a food drive still going on for this class, for all science classes that you were in, including Ag Science. Goes through May 21st, benefits second harvest of Tri-Cities. The final is on May 19th, Monday. The game project is due May 30th, so let's talk about that. The way I'm going to work it is each row in the rubric is some content that we covered in the class, and then each column is a score you're going to get. So, for instance, you could get a 4, you could get a 3, you could get a 2, you could get a 1. What we're going to talk about is the stuff you would need to cover in your game, like a question or cover that topic or somehow deal with that part of the class for level 1, a 2, a 3, or a 4. And then what I'm going to do is put check marks, and then I'll grade that up and then average all those, and then your final score will be the average of those columns. The things that we're probably not going to cover right here, they look like the stuff with 2 asterisks at the bottom, electron orbitals and blocks, ionization energies, pH, and the genesis of light. So we're not going to be covering that stuff, but the rest of the stuff we've all covered. Great work, first of all, staying focused this semester and getting through this material. This will help you out for your other science classes at school, and hopefully you've learned something. So here we go. The periodic table is organized into groups and periods. What is those exactly? The definition of a group is a column in the periodic table. The definition of a period is a row in the periodic table. You need to know some of the common group names: alkali metals, group 1, halogens, group 17, noble gases, group 18, and so forth. For level 2, use those in your game. Questions around that. Then know some trends that occur in the groups for level 3. So valence electrons, reactivity, we'll talk about those down below. Hey, there's some overlap between these. Don't let that freak you out. And you need to talk about this stuff in your game. There's also trends in the groups, and there's trends in the periods. So we talked about a few of those. Hey, and then for level 4, you should know some of the trends that occur in a period, like electron configuration, where the s electrons are, where the p electrons are, what the highest energy levels are, etc. Okay, going to line 2 here. Let's see. Let's keep track of these. We are on line 2, atoms and compounds. We did groups and periods. Let's do organization trends. The table is organized by the number of protons. That means that if you have a different number of protons, you're talking about a different element. Then, of course, that increases as you go across the table, and then increases as you go down. You know, every element has a number of protons, so we're set with that. The table has metals, nonmetals, metalloids, and elements are in groups that tend to be similar. That's at level 2. So you should need to know what the metals are. You need to know what the nonmetals are. You need to know what metalloids are. There's also reactivity trends for metals. And if you're in the metals, they're on the right side. The left side. They get more reactive as you go to the left or as you go down. And the reactivity trend for the nonmetals in general, they get more reactive as you go right and then up, and we'll talk a little bit more about what those trends mean. There's other stuff going on in the periodic table: atomic radius, electronegativity, ionization energy, radioactivity, stability. You cover some of that stuff. I can give you level 4 for this part of your rubric on your game. Atoms and compounds. We didn't talk too much about this, but we know that atoms are single objects, so like there is such a thing as a neon atom. Molecules are when atoms come together, like they get stuck somehow. And then compounds are made up of multiple atoms or multiple molecules, okay? That's for level 1. Just some of the basic definitions. Level 2, all the elements are atoms. Mixtures generally aren't pure. In other words, they can be made up of different atoms or different molecules or different compounds. Elements have to be pure. I mean, you have to be talking about carbon, just carbon, etc. Compounds can be pure in the sense that they have only like 2 things that are combined. And then mixtures are a bunch of things that are different atoms. So you understand compounds, it could be just H2O, right? Nothing else. No carbon, no chlorine, no nothing. But mixtures will tend to have water, chlorine, water's just an example in this case. 2 different molecules are mixtures. 1 molecule and just 1 molecule could be a compound. But a molecule can be made up of different atoms. You see how this gets complicated pretty quickly? So you can review that. And then knowing naming rules for how we put together more complicated polyatomic, so multiple atomic compounds for level 4. That's atoms and compounds. Here we go. Elements. All right, we talk about this a lot. Elements are the building blocks for all matter. Elements have names. Some elements have some good stories. You can review those. Some elements have different neutrons, so they're isotopes. But remember, protons define an element. And then for level 3, we know that elements react with each other. Some of our more famous or more useful substances like salt, sodium chloride, they're made up of elements, and there's patterns for how those come together. We've talked about those. Also, newer elements are man-made. I had an article too that was for extra credit reading about stability of large atoms, heavier elements. They start with just crazy names, and then they get assigned names, and then everybody agrees around the whole world what a certain element should be. And so that's why some of the elements are called by certain people, certain places. Yeah. Metals, nonmetals, metalloids. We're on line 1, 2, 3, 4, 5. What you've got is be able to define what a metal is, what a nonmetal is, what a metalloid is. Where are those on the periodic table? Compare and contrast metals. What is similar? What is different about them? Know some chemical or physical properties. So once again, we're talking about your game. Your game needs to use these words. Metals, nonmetals, metalloids. Your game needs to show me that you understand what those are. Okay, what is a nonmetal? What is a metalloid? This is the rubric line that talks about you showed me that you know what you're talking about when it comes to metals and nonmetals. For level 4, you need to be able to predict behaviors of metals or nonmetals based on their location. All right, and then level 3, where they are in the periodic table, and then use examples. All right, here we go. Physical, chemical properties. Define physical or chemical properties. Give an example for level 1. Know how physical chemical properties show up on the periodic table. So where are certain physical properties? Where are certain chemical properties? And then give examples of elements at level 3 with certain physical and chemical properties. Know important exceptions on the periodic table. I haven't thought of a level 4 yet. Maybe level 4 is about other physical or chemical properties that we didn't necessarily focus on. So these are some examples of physical and chemical properties. Notice there's a lot of physical properties. We're not talking about all of those, but there are a lot, and there are relatively few chemical properties, or chemical properties are relatively specific. All right. So, and then there's some words, remember, that some people had problems with, like ductility, malleability, etc. Hey, review those. Review your glossary for the final. It'll help you out. Atomic models. You need to know what the current model of the atom is. Nucleus, where is that? Protons, where are they? Neutrons, electrons, where are they? What is their charge? Hey, you need to know what their relative masses are. Which one is the heavier one? Which ones are the lighter ones? Protons, neutrons, heavy. Electrons, relatively light. All right. You need to know what some significant developments are in the model of the atom. When did we find out about a nucleus? When did we find neutrons? When did we find electrons? You should be able to sketch those models or depict those in some graphical way. Okay? And then level 3, know the discoverers of certain basic parts of the atom, when they did their work, so what century or what years, and then know the names of the experiments that they used to show or to develop their understanding of the atom. Names that come to mind: Thomson, cathode ray tube experiment and the electron; Rutherford, gold foil experiment. And that atoms were mostly empty space, but there was a hard nucleus, or there was a concentrated nucleus of positive charge. Then neutrons, Chadwick. Electrons can jump, Niels Bohr. So we get certain energies from atoms as electrons jump. And then there was Schrödinger, who said that electrons, we don't really know where they are. There's kind of a cloud of electrons, sort of a probability of where they are. And you can review those. I have another video about the history of the atom. Hey, and for level 4, if you can talk about the quantum view of the atom, or how we think about the atom based from quantum mechanics and physics, great, level 4. There are certain subatomic particles you need to know about: proton, positive charge; neutron, negative charge; protons and neutrons, relatively similar masses; electrons, very light, negative charge, outside the nucleus. Alright, so you need to know the location. Level 2, you need to know that neutrons determine isotopes, electrons determine ions and reactivity. So you need to know how these subatomic particles affect the atom. Be able to describe an atom in terms of the number of protons, number of neutrons, and number of electrons. Or if I give you those, you need to tell me about which atom I'm talking about. That's all about subatomic particles. We're here, line 6, 7, 8, line 8 on the rubric. Hey, and then for level 4, there's some crazy particles out there named quarks, neutrinos, muons, tau particles. Hey, if you want to do some research on those, put those in your game, you can do that. Real quick, this is called the nuclide symbol. When I put an element here and then surround it with some numbers, the number on the upper left, that's the mass number. The number on the lower left is the atomic number. On the upper right, you have the charge, and then the symbol that we're talking about goes in the center. That's all called the nuclide symbol. Alright? Alright, isotopes and ions. So along with that picture we just saw, you need to know what an isotope is. You need to know what an ion is. You need to know how isotopes are made, basically by removing or adding neutrons. You need to know how ions are made, adding or removing electrons, or adding and removing protons, but of course the atom changes. You need to know about common and uncommon isotopes for level 3. We talked about this, we drilled on this. Isotopes can have a different mass than what is most common, and the most common mass for an atom is on the periodic table. You can look it up. Alright, and then know that ions attract, especially if they're opposites, positive or negative. Hey, for level 4, if you've done some thinking about multi-atom ions, how they are made, how they react, you can put some of that in your game. And then if you have some familiarity with the table of radionuclides, that's about radioactive elements. That's about isotopes that only last for seconds or milliseconds. You can do a little research on that. I can give you some resources. Okay, do you remember Percy Copper, Lena Chlorine, and Sirius MG, a little song I sang around St. Patrick's Day? We're talking about single replacement reactions. What it is, it's where two atoms are together and one comes along and then swaps out. And so now these two are together and this one is all by itself. This has to do with reactivity. So why certain atoms replace other atoms or elements in a molecule is because of reactivity. And we had a quiz on this. You need to be able to predict when that might happen, and need to know what might be the limits of a single replacement reaction, so mole ratios. For level 4, there are some ways to predict when that's going to happen. In more detail, how much heat you're going to get, you can do some research on that. here's what it looks like basically schematically. You've got A and B, two elements stuck together. You throw in an element C. What happens then is element C kicks off, C is green, kicks off A, and now B and C are together, and A is by itself. That's kind of just a basic picture of a single replacement reaction. That's what we're talking about in that case. All right, ionic and covalent bonding. We saw a video on this. We talked about, I think we did a little bit of worksheet on this, but anyway, ionic bonds are when atoms, one atom removes, or one element removes an electron from another one. And covalent is where two atoms share electrons. Remember that the octet rule says that octet means 8. Atoms are trying to get to 8 electrons on their outer shell. That's when they're most happy. That's why the noble gases don't react, is because they have 8. If you've got an element with 1 electron, but it's kind of just a loner, and you have another atom that's got 7, it wants 8. So they're perfectly willing to, like, let's say this atom gives up that 1, make that one happy, and then their ions, they attract. That's ionic bonding. Or, so that's most often ionic between metals and nonmetals. If you've got a nonmetal and a nonmetal, they'll tend to be covalent. They'll tend to share electrons. They don't give it up. So you need to know an example of that, an example of ionic sodium chloride, an example of covalent water, H2O. Compare and contrast the two, like I said, which one shares electrons, which one gives or donates electrons to another. So then be able to predict if two elements are going to do that. Remember, nonmetals will tend to share, and metals will tend to give up electrons. And then there are larger, more complicated covalent bonds where more than one electron gets shared. They're called double covalent and triple covalent. You can do some research on that for level 4 in your game. How and why things come together, that's kind of the magic of chemistry, right? Like why this one atom will react with this other one. Knowing how to predict some of that is what we're talking about when it comes to chemical bonding. Which chemicals are most reactive? Which elements give up electrons? Those are some basic factors for level 1 in this question. And then know some reactivity trends or some bonding trends. How many electrons does an element give or take? That depends on the group you're in. Know some exceptions to those simple trends and why we need to have those. And then there are more powerful tools for predicting which elements are going to react. You can do some research on that for level 4 on this question. Ladies and gentlemen, we're on line 9, 10, 11, 12. We're on line 12. We have 4 more to go, so thanks for hanging in there. Valence electrons, what's the definition? They're electrons on the outer shell. There are some trends in valence electrons. You have 1 valence electron in group 1. You have 7 valence electrons in group 7. That's some of the trends we're talking about. Metals tend to give up electrons, so they become cations. Nonmetals tend to take electrons, they become anions. There's some exceptions to valence electrons. The transition metals, you have to look those up, they're not as easy. And also there's helium, which has only 2 valence electrons. That is an exception. And then of course the noble gases don't react, so those are some exceptions. And then knowing more about like the transition metal story for valence electrons, that could be a level 4. So these are the levels of material you need to talk about, or ideas you need to talk about in your game for valence electrons. Line 13. All right, line 14. Electron dot diagrams. These are the orange sheet we did. This is about depicting how many valence electrons an atom has using dots. 8 dots is kind of you're full up, you're good, you won't react with anything. Less than that means you want to give electrons or take electrons. And so level 2 means you can, level 1 means you can do that. Level 2 means you can see that and make predictions. And level 3 means you can do more complicated stuff with these diagrams instead of just one atom, more than one atom. And then there's Lewis dot diagrams, LDDs, for whole molecules, so you can review those as well. All right, historical look at chemistry. This is line 15. Remember that the history of the atom is the history of thinking about whether they were just solid objects or whether they were kind of puddings, like positive with like sprinkles of negative charges, or whether they were empty space with electrons whizzing around, mostly empty space with a nucleus in the center, and then if there were clouds of electrons. So need to know some of that story of how chemistry came along. Major discoveries. There's also stuff like the conservation of mass or combustion, how that stuff came together into chemistry. You need to know some of those names. Lavoisier, for example, Dalton, etc. You also need to know the time frame of the discovery of some of these topics, and then you can cover, if you want to cover other scientists, women, African American scientists, other people who impacted our understanding that isn't these white dead guys. That's fine for level 4. So go do some work there. That'd be great. All right, line 16. Life elements, in other words, the elements that are needed for life. What does CHNOPS stand for? CHNOPS. Do we know this? Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These are the elements that are necessary for life. Why are they necessary for life? Why are they necessary? What do they do in our bodies? You need to know some of that. This is on the final. This should be in your project. What is the significance of these elements for our life processes? What might happen if they're absent? Do some worst case scenarios there. And then there are other implications for these elements if they're found. Does it mean there was life there or not? What's true on Mars? You want to do some work on that, put that in your game. That's a level 4 for life elements. Okay, ladies and gentlemen, that's it. That's what you need to have in your game for full credit, for extra credit. It's also helpful to do your game. Be working on your game. You can work on your game as a review for your final. Here's some other ideas for studying for your final. Take a look at chapter 7 in the book. http tiny.cc Mr. W book, all one word. MRWBOOK to get to the book for this class. Take a look at your notes or in your notebook. Take a look at the handouts that we've been doing, and take a look at the learning progressions. That's the standards that we've been covering for your final. All right, last but not least, let's say you're not so far on your game. You don't know what you're doing exactly. You're still kind of undecided. Take a look at this take a look at this website, www.equizshow.com. Make a little Jeopardy game if you're not working on a game project. You can still get some points. You still need to cover some of the material. If you cover it all, full credit in the course, in this presentation that this video that we've been talking about right here. Don't not do a project. It'll hurt your grade. I'm looking forward to seeing your projects. I know some of you have been doing a great job. I know some of you need to get started, but you still have time. Thank you so much for listening. It's Mr. Weisenfeld.